Alright, so this is lesson number 77 in Algebra 1, and consecutive odd and consecutive even integers, fraction, and decimal word problems. So we'll see if we can do this in one video or whether it's going to take two. Alright, so we talked about consecutive numbers in the last lesson, and that was if we had one number and then we added 1 to it, and we added 2 to it. So if this number were a 6, this would be a 7, this would be 8. Those are consecutive. Now what if we had consecutive odd, or consecutive even numbers, like 6, 8, 10, 12? Well, if this were n, how would we get to our 8? We would take whatever that n was and add 2 to it, right? 6 plus 2 is 8. Then we'd take 6 plus 4 to get 10, and 6 plus 6 to get 12. So notice when we're doing consecutive even numbers, we add 2 to get the next one. We add 4 to get the next, because we're skipping one. Okay, we're skipping the in-between. We're skipping this one right here, n plus 1, because we won't care what the odd number is. We want the next even one, and the next even one is 2 away. So in order to get to even numbers, we have to go 2 to get to each one. Alright, now this is what gets kids a little bit confused if we're going to do odd. So let's say that we're doing 7, 9, 11, 13. Our first number is n, right? What is our next one? What did we have to add to n to get 9? 2. And what did we add here? 4. And what did we add here? We did not add 5, we added 6. So notice that when we're looking for consecutive even numbers, we add 2, 4, 6. When we add consecutive odd, we add 2, 4, 6. These numbers here have nothing to do with what we're looking for. They don't have to be odd numbers, they're going to be even numbers, because what's happening is our first number is 7, our next one is how far away? 2. Our next one is how far away? 4. Our next one is how far away? 6. It's the same distance away. It's just we're starting with an odd number, so that when we add 2, we get another odd. We add 4, we get another odd. We add 6, we get another odd. Up here we started with an even, so when we add 2, we get an even. Add 2, we get an even. Add 2, we get an even. Okay? So, if it says find consecutive even numbers or consecutive odd numbers, you will use these same parts in order to find that. Alright, so let's go ahead and give this a shot. You will make mistakes. Everybody always does. They just can't figure out how consecutive odd numbers use even numbers. Alright, so example 77.1. Find 3 consecutive even integers. Such that the sum of the first and second. The sum of the first and second equals the sum of the third and sum and negative 10. So it says the sum of the third and negative 10. So a sum, that's why I put a plus sign there. So 2n plus 2 equals n minus 6 plus 4 minus 10 is negative 6. Subtract n from both sides, and we have n plus 2 equals negative 6. Subtract 2, n equals negative 8. So if n equals negative 8, then this is going to be negative 8 plus 2, which is going to be negative 6. And this is going to be negative 8 plus 4, which is negative 4. So there are my 3 consecutive even numbers, negative 8, negative 6, negative 4. Okay? Now let's look at 77.2. Find 3 consecutive odd. So remember n plus 2, n plus 4, not n plus 3. Such that the sum of the first and third is 7 greater, leave myself a space, is 7 greater than the second decreased by 8. All right, what do we know about, or decreased by 18? What do we know about this one? It's 7 greater. It's 7 bigger than this here, so they're not equal. In order to make them equal, if it's 7 greater, I have to take that 7 away in order to make them equal there. Alright, so let's put this section together. 2n, n plus n. Okay, let's keep simplifying. Okay, subtract n. So 2n minus n is 1n minus 3 equals 16. Negative 16, I mean. Add 3. And equals negative 13. Now if we use this up here, we get n is negative 13. N plus 2 is negative 13 plus 2. Let's get this out of my way. Which equals negative 11. And then n plus 4 equals negative 13 plus 4 equals negative 9. So negative 13, negative 11, negative 9 are my 3 answers. So don't forget, you're not just finding what n equals, you're finding what all 3 of the numbers equal. And sometimes you're just going to give me what n equals because you're going to forget that you're supposed to give all of it to me. Alright, so let's look at fraction and decimal word problems. And I would suggest you ignore the part where it says use these dumb diagrams. Alright, so let's just look at example 77.4. Lopez used a 5-iron. Okay, you don't need to know anything about golf. Okay, but the ball covered only 4/5 of the required distance. Okay, so he hits the ball from here, and it doesn't go that far. It only goes 4/5. Alright, so this is 4/5 the distance, meaning we're 1/5 short of hitting it the whole way. And it says that if she hit the ball 112 yards, so 4/5 the distance was 112 yards, what is the required distance? Alright, so let's look at this. We have 4/5 of multiplication the total distance. That's how far she hit it. 4/5 of the total distance. And that 4/5 was 112 yards. So if I take 4/5 times x, that gives me 112 yards. And if I divide both sides by 4/5, 4/5 over 4/5, and then I take this, turn it upside down and multiply, I will get my x. Okay, so if I were to take 112 times 5 divided by 4, I will get 140. And that is how far she hit it. Or that's the total. I guess I should draw that different. That is the total distance that she was supposed to hit it. But she only hit it 112. Okay, so it's just using the same formula of the of means multiply, is means equal that we've been doing, only we're using fractions in these instead of just whole numbers. Alright, so let's look at example 77.5. Maccabee guessed that the total was 30.24. But this was 7.2 times the total. So the number that Maccabee guessed was 7.2 times the total. Okay, see what I did there? She guessed, or he guessed, whatever a Maccabee is, guessed 30.24. That was 7.2 times the total. What was the total? Okay, so 7.2, our total is x. Divide by 7.2 to get rid of that. And we get a number of our x, or our total, is 4.2. That's the answer. And if we take it and multiply it by 7.2, we should get that number back. Alright, let's keep going here. Last example. 3/4 of the tickets had been sold. So 3/4 of the tickets, 3/4 of the total had been sold. And there were 420 tickets left. Okay, so 3/4 of the total is how many were sold. Okay? We don't care how many were sold. We know that we had 420 left. So we're interested in what were left, not what were sold. Alright, so 420 left. So 3/4 of the total was how much are sold. So that means if 3/4 were sold, how many were left? 1/4. 1/4 of the total were left. 1/4 did not sell. 3/4 did. So how many were left? 420. That's how many were left. So 1/4 of x, the total, is 420. Divide by 1/4. Divide by 1/4. Those cancel. So we have x equals 420. Remember, an invert multiply when you divide fractions. And we have 1680 tickets that we had as a total amount. So we had, out of that 1680, 420 were left over, and then we had sold, you know, whatever the difference between 1680 and 420. What is that? 1260. Okay, so you see what I did there? I took 3/4 of the total is how many were sold. Well, they gave me how many were left. So it's not 3/4 of the total that were left, it's 1/4, the rest of the fraction that makes it 1. So 3/4 plus 1/4 is 1. So 1/4 of the total is what is left, and that's the number that they gave us here. So make sure when you do these, you read the instructions, because they will try to trick you on some of these. So if you look at, well, let's see if they give us any that are kind of tricky. Let's see, number 1, 2, you'll be fine. 3, don't worry about drawing a diagram. 7, 8, we're in red. 4, 5, 6. Maybe they're not going to give you any tricky ones in there like that one. Alright, so you should be okay for lesson number 77.